Good morning. Today in this class we want to take off roof, and we're told, if you look at this plan, we are told to take off roof using this plan. So when we are taking off the roof, the first thing is to develop what's called the checklist. Where I say the checklist of the roofs, first of all we need to have the wall plates as the first one. Upon the wall plate we'll be doing what is called the trusses. After trusses we go for purlins. Then we go for ridge board. After ridge board we go to face board, and we go to the last one, sixth one is the roof covering. On the trusses, these are the things we want to measure on the trusses. We have the rafters, we have the king posts, we have the queen post, we have the standing beam, we have the tie beam, then we have princess post. So that's it. So if we start with the wall plate, one wall plate. Wall plates will always place them along the edges of this structure. So it simply means the perimeter of this figure. So, and we knew our center line, so we can get the center line of that one. This will be 2. Perimeter of that figure is 2 into length plus width. We'll have 2 into 7600 plus 4500. 4500 to be 12,000. This one is 12,000 times 2. Times 2 is 12,000. 100 times 2 will give us 24,200 millimeters as the perimeter of that. So this is what we place as the timber for all rounds. So on the description, we normally know that timber that is being used in wall plates are always 100 by 50 millimeters thick, or pre-treated, because this thing must be treated, pre-treated. Cypress, let's assume we are using cypress timber on wall plates. So this is the description. We have described what we are using, but on the entry column we have to enter that, which is 24.20. Then we close that. So that item is completed. If you go to trusses, first of all you have to draw. So let's start. Number of trusses is equals to length over spacing, and say assume, because we are not being told. These are the things we can say. Assume trusses are spaced at 1200 millimeters center to center. So from one perimeter is equals to, number of trusses now will be 7600 millimeters divided by 1200 millimeters plus 1, because from one truss to another we'll have another one. So we need 1 plus 1 truss to give us 8 number of trusses. So we have 8 number of trusses that we have to place from one end to the other. Then this is how our truss will look like. This is how the truss will look like. We have the king post, we have the standing beam, then we have the queen post, we have the princess post. These are the princess posts. That's the truss. So this is called the hip rafters. Hip rafters. This is the queen princess post. Princess post. This is what is called the queen post. The queen post. This is what is called the tie beam. This is the king post. The king post. So that's it. So let's start with the rafters as the first item. Rafters. If you look at this side and you're told in normal circumstances roofs are always rising with an angle of 30 degrees. That is always the standard angle that all roofs are rising with. So if we have 30 degrees here and always you know that all roofs are in the shape of isosceles triangle, so this angle will also be 30. But from some of the angles in a triangle, they will always add to an 80. It means if you have 30 plus 30 will give us 60. 60 minus 180 is 120. So it means at this peak we have 120 degrees. But because this angle has bisected it into two, it means this side will have 60 degrees and also 60 degrees. So in our final we'll have a triangle in this shape. In this shape where we have 30, we have 60, then we have 90 degrees. We don't have the king post, but we have here. Because these our trusses are always being aligned on the shorter side of the truss of the room, and it means we are going to arrange these our trusses in this format. So all of this length from extreme of the trusses, or the length of the standing beam will be 4500. But now we have only taken one side of this truss. So it means a half of 4500, where we'll have 2250 millimeters. From the trigonometric ratios, we know that we have what is called the SOHCAHTOA. SOHCAHTOA, where we mean tan theta is equals to opposite over adjacent. This is the opposite, this is the adjacent. So now we can get the opposite. So we say tan 30 is equals to opposite, which is x, over adjacent, which is 2250. Now x will be tan 30 by 2250, of which of course you will have it as tan 30 times 2250 tan 30. We'll have this as 1299.03. So this is what is there as the king post. So when we want to describe, it is always the size of the timber is always 100. We say 100 by 50 millimeters, pre-treated cypress timber, to king post. On the entry column, we have to enter this, where we'll have as 1.3, because if you round off, it comes 1300. So we have 1.30, enter. All timbers are being measured into linear meter. But because we had known that we have 8 number of trusses, on the timesing column we have to multiply by 8. So we have completed that entry. Let's enter what is called the tie beam. The tie beam, say 100 millimeters by 50 millimeters thick, pre-treated cypress timber, to tie-beam. We know that the length of the tie-beam becomes 4.50, but we had such number of tie-beams, so we multiply by 8, and that's entry is correct. So we're done with the wall plate and the tie-beam. So it means we have done with this, and now we can get the rafters. So this will be our rafter, and we now have this as 1299. We can use Pythagoras theorem to get the hypotenuse of that figure, because it's a right angle triangle. So from the hypotenuse is equal to base squared plus height squared and the square root, where our base will be 2250 squared plus 1299.03 squared and the square root, to have that as our hypotenuse. 2250 squared plus 1299 will have 2298.07 as the rafters. But we always add 1000, say allow 1000 millimeters for eaves. So it means we have to add 1000 on top of this. So it will be 1033, 35, 98.08. So on the entry, we say 100 by 50 millimeters pre-treated cypress timber on or for hipped rafters. So on the entry we enter 3.60, and because we have 8 number of trusses, but we have only, if you look at this one hipped rafter. It means in one truss we have 2 number. So here we say 2 number, but we have same such trusses. So this entry is completed. Let's go to the straining beam. And say, assume straining beam is placed at 1/3 of the king post. So it means from this distance up to here it will be placed at 1/3 of it. So it means we'll have something like this. So we have the straining beam. So this 30, this will give us 90, this will give us 60, this will give us 30, because it should make 90 degrees to the apex. Then we have also 60, here is 90, 60 plus 60, here is 30, it means we'll have 60 degrees there, again we'll have 60 degrees, and there will be 30 degrees as those angles. So we have this. So 1/3 of king post was 1200. 1/3 times 1200, 12,900. will give us 433 millimeters. So it means we have 433 millimeters, while we have that angle as 30. So we can get adjacent, because tan theta, tan 30 is equal to opposite, which is 433, over adjacent, which is x. So it means x is equal to 433 divided by tan 30, giving us 749.98, around 750 millimeters.
So we know that the manipulation, but I will say, if I put a minute or so, we will get the issues.
So again we have 100 by 50 millimeters pre-treated. Cypress timber on selling beam. Because the length now becomes, the length is 750, which is 0.75, but there are two, because this is only for one, we multiply by 2. Again, we had 8 such number of trusses. 8 such number of trusses will give us that, and close that your entry. Let's go to queen post. Queen post. If you look at this triangle, we now be using this triangle. We'll have something like this. Something like that of that side. We have 60 degrees. We have 90 degrees. Then we had 30 degrees. Then we had this one we have given, we had as a 750 millimeters. And now we had this also as 1299 minus 433. As 866. 866. Now we can get hypotenuse by saying hypotenuse is equal to base squared plus height squared under square root, giving us 750 squared plus 6866 squared on under square root to have that squared plus 750 squared under square root, giving us 1145.62 millimeters. So this is what we enter onto that pin post as 100 by 50 millimeters pre-treated cypress timber on queen posts. Queen post. Because we have the length as 11, so it will be 1.15 on our entry column, 1.15, but we multiply by 2 because in one class we have to start 2 numbers, but total number of trusses are 8. So we close that entry. Then before we finish with the trusses, let's do with the princess post. The princess post. Princess post. Princess post. This is the princess post. And we have something like this. Something like of this such. we have 60 degrees. We have this length as the queen post as 1145 millimeters. Then we don't have this, so we need this opposite over hypotenuse. That is
2 units in the left, 2 minus.
So it simply means we use sin theta. Sin theta is equal to opposite over hypotenuse. Now because we don't have opposite, therefore opposite is equal to sin 60 times hypotenuse, it is 1145, giving us sin 60 times 1145. Nine 91.59. So this is what we have. So we enter again 100 by 50 millimeters pre-treated cypress timber to princess post. Then we enter that as will be 1 on 0, but we have such two numbers, then again multiply 8 numbers, then close. So we have done the truss. You can go to the you can start taking off of the purlins. No, let's go for the jack, chapel and common rafters. All trusses are shaped in this form. All roofs will having this form. So it means this is the jack rafter. Then we have the, if you look at this, there's a truss that will be this side. Then we have another truss in this shape. I think this will give us the best truss than whatever we are doing. So this is the first truss that we have. So if we have the king post, so we have the king post, then we have an angle to the jack, to the common rafter, then we have this distance. And we say all trusses are placed at 1200 millimeters center to center. So it means there will be 1200 millimeters. Then we had this as 1299 millimeters. Then we don't have that. So we can get the square root to get. So square root of now common rafter. Is equals to 1299 squared plus 1200 squared all under square root. You have 1299 squared plus 1200 squared under square root 1768.45 millimeters. So it means this is the distance from the edge to the edge is 1200. Then we know the king post. So we enter that as 100 by 50 millimeters thick pre-treated cypress timber to common rafter. then you close. The entry will be 1.7977, 1.77, but because all these our jack drafters, one will be here, one will be here, we multiply by 2. I think we are correct. Let's go to the jack drafters. We'll have this triangle. We'll have a triangle in this shape. If you look at this, now we are in this triangle. It will be 90 degrees there, and we are saying this angle is 30. It means we'll have a peak at 60 degrees. So there is 60. We have 30. Then we knew this line as 1768 millimeters. Then we will need this. We don't know how we can get this. So cut off. So you see, sin 30 is equals to opposite, which is 1768, over hypotenuse, which you don't know. So mean hypotenuse is equals to 1768 divided by sin 30. Which simply means 1768, 68 times 2, because sin 30 is 0.5, giving us 35, 34, 36 millimeters. But we had 1,000 because we have an heap, or 1,000 and if plus 1,000 to give us 36 millimeters. So say 100 by 50 millimeters pre-treated cypress timber to jacked rafters. Then you close, enter that as 45. This will be now 4.54, but we have 4 number of 1, 2, 3, 4 at the corners, and we multiply by 4. Because of the time, in our next class we will be taking off the purlins, the ridges, faceboard, and the roof covering. Thank you for participating in class.